So we want to find the magnitude of the essentially the boat relative to the shore, the magnitude of the velocity of the boat relative to the shore, and then during after 3 seconds, what's its position. So we can draw this out. This arrow, right, we can say this, there's a theta defined here, and then there's a angle phi with the horizontal. This vector right here will represent the boat relative to the shore. This right here will represent the boat relative to the water. Sorry, relative to the water. And then we can say that this velocity is the water relative to the shore. We're going to label this as vector 1, this as vector 3, and then this as vector 2. So we can say that the magnitude of vector 3 is going to be equal to the square root of the vector 1 squared plus vector 2 squared, all to the 1/2 power. There it is. So that would be the formula, and that would be equal to 1.2 squared plus 2.2 squared, and this is all to the 1/2 power. So the magnitude of the boat relative to the shore is going to be equal to 2.51 meters per second. So this will be the magnitude. And if you wanted to find the angle, we can say angle is going to be tangent -1 of 2.2, the y component, divided by the x component, 1.2, and this is giving us 28.6 degrees. Now this equals a theta. We want to find relative to the shore. So we can say phi simply equals 90 minus theta, or we can say 90 minus 28.6, and this is giving us 61.4 degrees, again, relative to shore. So this will be our final answer for the direction of the boat, of the velocity of the boat relative to the shore. And then for part B, they're asking us for the change in displacement, and this is going to give us 1.20, comma 2.20 meters per second, and then this will be times 3.00 seconds. So we can say that this is going to be equal, so delta D, the displacement, is going to be equal to 3.60, comma 6.60 meters. This would be downstream, and then this would be across the river. So at this point, we can say that if we wanted to find the magnitude of displacement, we can say that the magnitude of displacement equals, again, 3.6 squared plus 6.6 squared, all to the 1/2 power. And this is giving us the magnitude of displacement is 7.52 meters. And then theta would be arctan of the y component, 6.6, divided by the x component, 3.6, and this is giving us 28.6 again. And then, of course, phi would be 61.4 degrees. And if you wanted to get the components, this could be also an answer. That is the end of the solution. Thank you for watching.